Welcome to this video that provides an introduction to the characteristics of human environmental exposure data. Only one who thinks that exposure data are often right-skewed and often reasonably fit a log-normal distribution. Many people, in fact, have made that observation, and that knowledge has existed for a long time. Take, for example, the original version of the Guidelines for Exposure Assessment published by the U.S. Environmental Protection Agency in 1992. Here's an excerpt from that report that discusses right-skewed exposure and dose data and resembling a log-normal curve. Here's a later report, this came out in 1997, where EPA is discussing environmental applications of the log-normal distribution. So, not unknown, in fact, well-known. Here's an example, just another example of the use of the log-normal in practice. Here's a figure, an abstract reproduced from this paper, which is reporting on distribution of blood lead levels in a birth cohort of New Zealanders at age 21. So there's a histogram of blood lead measures at age 21 for females, shown in blue, and for males, shown in black, and you can see that the right-skewed nature of the data. And then I encourage you to read through the abstract here, and you'll see that the authors refer to the geometric means of the distributions when describing them, and they actually talk about conducting hypothesis tests on the geometric means, and i.e., in other words, the means of the logs. This paper was published in 1975, and you can see again with the sperm count, so this is sperm per milliliter, so millions of sperm per milliliter of ejaculate. And again, you see that classic right-skewed approximately log-normal characteristic. In fact, you can, and I reproduced a portion of the results section here on the right, and you can see the authors report the arithmetic mean was 79 million with a standard deviation of 57. However, for reasons given under discussion, we considered the mean of the logarithms to be more representative. This corresponds to a geometric mean of 65 million with one standard deviation, limits of 30 to 142. These limits correspond closely to the 16th and 84th percentile. So they're trying to describe the GSD without actually bringing that term in. Anyway, I thought this was all interesting and another useful example. So that's the information in this slide deck and this talk on the right-skewed environmental exposure distributions and how the log-normal distribution fits in there.